Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ariz Zaham from Group 1. For Experiment 5, Pelton Wheel, I will present about the Chapter 1. First, energy may take many different forms. Hydraulic energy is the energy that a fluid can have. Kinetic pressure, potential, strain and thermal energy are all examples of potential energy. Hydraulic energy is converted into mechanical energy using fluid equipment. Turbines are used to generate mechanical energy from hydraulic energy in this way. The example of Pelton turbine. Second, the problem statement. There is a distinction to be made between theoretical and experimental efficiency. The fundamental variation in efficiency is a frictional impact. We ignore the influence of friction in the theoretical calculation. Yet the friction is crucial factor in determining efficiency in experiment. There are also some human errors such as equipment handling, reading and calculating result. These variables also help to diversity the efficiency difference between real and theoretical value. For the objective, we have three objectives. First, to investigate the performance of the Pelton wheel turbine with constant pressure. Second, to identify the rotational speed, torque and power output of Pelton wheel turbine. And last, to determine the optimum efficiency point. For the scope, first, test the Pelton turbine at a constant pressure. Second, measure the reading of rotational speed and power output.
Assalamualaikum warahmatullahi wabarakatuh and good morning. My name is Ahmad Wa'idi Muhammad Azmi. So for my part, I will present about chapter 2, which is theory. So for the chapter 2 theory, we talk about the working principle of Pelton turbine. So Pelton wheel turbine consists of elliptical shape, vanes or bucket which attached to the periphery of rotating wheel. In the turbine, the total head available is first converted into kinetic energy at the nozzle exit. Then the jet coming from the nozzle will strike the vane attached to the periphery of rotating wheel. The energy is transferred because work is done on the runner by the fluid due to the rate of change of angular momentum and motion of vanes. The absolute velocity at outlet is smaller than that in the inlet because fluid energy is gradually reduced when passing through the runners. Pelton wheel turbine is mainly used for high head and low flow rate application. So this is the example of Pelton turbine. As you can see, there is the hand wheel, stopper, support, spear, the nozzle, braking jet, bucket, runner, feed circle, casing and the tail stop. So next is the Pelton wheel part, as you can see from the picture just now. So the runner with bucket is the function is consist of circular disc on the periphery of which a number of bucket are fixed. So second is the nozzle. The function is water coming from the reservoir through penstock is accelerated to a certain velocity by means of nozzle. Number 3, spear. It's control the amount of water striking the bucket of runners. The number 4 is casing. It prevents the splashing of water and discharge of water to tail race. And the lastly is the braking jet. The function is small nozzle will stop the runner in a short time. So next, for the calculation for the Pelton turbine, so it uses the Newton's second law of motion with respect to the angular motion, which is angular momentum is equal to mass times tangential velocity times radius. Its torque is equal to rate of change of momentum. Power is equal to torque times angular velocity. So it consider the water jet striking the runner generating torque T and rotate the runner with n revolution per minute. the power output can be expressed as P out equal to T omega in unit of watt. So second is omega equal to 2 pi n divided by 60. The unit is rad per second. So the total head available at the nozzle is equal to the gross head nozzle in the pipeline leading to the nozzle penstock and denoted by H, plus the power input to the turbine can be expressed as P in equal to rho G Q H, where P in is equal to power input to turbine, H is the total available heat meter, rho is the density of water in kilogram meter power of -3. Q is the volume flow rate of water in meter power of 3 per second. G is the gravitational acceleration in meter per second power of 2. So in order to evaluate the performance of Pelton with turbine, the overall efficiency can be calculated from NO equal to P out divided by P in, or P omega divided by rho GQH. So that's all from me. Thank you.
Hi and Assalamualaikum. My name is Noatika binti Ahmad, MA1A101. For this experiment, I will present about the methodology. So the experiment is setup and procedure. For this experiment, we use equipment Pelton Turbine HM150.19 and hydraulic bench HM150. For this experiment is to measure the flow rate by time and speed of Pelton wheel. The procedure for Pelton wheel turbine experiment is, before we start the experiment, we should make sure all the connection of the water has no leak in hydraulic bench. The flow rate is assumed on the water to hydraulic bench, and nozzle valve is determined on rotational valve by turning the net cut. The nozzle position can be adjusted by the nozzle adjustment, and the pump is turned on, and flow control valve must be in a vertical flow. The storage tank must be filled full of water. The water from the storage must be pumped to measure tank flow rate. We measure the flow rate from the water pump. Then time taken is recorded when measuring tank level reach 10 meter, 10 to 20 liter. Then the data collect and record from the tachometer to get speed for Pelton wheel. And that's all for the experimental procedure. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hanif bin Saiful Nizam. My method ID is MA18108. Today I will continue from my part, which is a result and definition for the experiment. The first result that we get is a sort of table data, which is about the turbine characteristics curve. In this table, we get a rotational speed in Newton meter, moment on the shaft, power output in watt, power input, and also the percentage of efficiency. From this table, we already have a graph, which is a torque versus rotational speed graph. This graph shows the relationship between Newton meter torque and rotational speeds in RPM. The result that we get is torque will decrease when rotational speeds increase, and the maximum torque produced in this experiment is around 0.1325 Nm at 286 RPM. The next data that we get is about the power curve. In this table, we have rotational speeds in RPM and also the power output in watt. From this sort of data, we already have a graph. We get the graph. It's about power output versus rotational speed graph. From this graph, we get that this graph shows a power output versus rotational speed graph that has been plotted from the data that given from the slide. And also the average efficiency of the turbine is around 55.8%. Last one is we get the maximum power output is 3.2 watt at 470 RPM. That's all from me. Thank you.
Hello, my name is Kumaresan. Matrix number is MA18163. So now I'm going to talk about the conclusion. So a tachometer was used to measure the speed of a Pelton turbine during an experiment to determine its power output. So due to a pump operating at a steady speed, the examination found that there was a low head. The valve change had a small impact on the flow pressure. The flow through the nozzle was manipulated, but the pressure when jet hits the bucket could easily fluctuate, but energy created was not enough on wheel. The flow rate through the nozzle increased when the valve was moved from the least to the most extreme setting, which causes increase in the bucket's power when the jet hits the splitter. So from this experiment, so the following conclusions can be drawn. So a large hydropower plant could be built with a Pelton turbine operating at high head and low flow with high pressure, while a low head, high flow with low pressure yield less power. This is the reference that we used and we have included in the report. So that's all from me. Thank you.